Power transformers are critical components in electrical systems. To ensure their reliability and safety, a series of electrical tests are performed to evaluate their condition. We begin with the insulation resistance test. This test assesses the quality of insulation between the windings and ground or between different windings. Using a megometer, we apply a DC voltage and measure the resistance. There are 3 connections of the insulation test: high voltage ground, and low voltage ground. The first one is connecting the positive port with high voltage winding and the negative port to the low voltage winding. The second connection is connecting the positive port with the high voltage winding and the negative port with ground. The last connection is connecting the positive port with the low voltage winding and the negative port with ground. According to NETA ATS, and for Table 100.5, a high resistance value indicates good insulation, while a low value signals potential degradation. Next is the turns ratio test, which ensures that the ratio of primary to secondary windings matches design specifications. A low-voltage AC signal is applied to the primary winding. The voltage induced in the secondary winding is measured. The turns ratio is calculated by comparing the primary and secondary voltages. According to NETA ATS, the measured turns ratio should not deviate more than 0.5% from the design ratio. Any deviate more than the expected value, it could indicate winding issues. Sweep frequency response analysis, or SFRA, detects mechanical changes in the transformer's windings or core structure. By applying a frequency variable sinusoidal low-voltage signal, typically ranging between 0.1 volt and 10 volt with frequency range of 20 Hz to 2 MHz. The parameters of power transformer such as resistance, inductance, and capacitance could be indicator of mechanical fault. Assessment methods. Time-based comparison. Current SFRA results are compared to previous results on the same power transformer under test. Type-based comparison. Current SFRA results are compared to another power transformer of the same design, sister unit. Phase-based comparison. Current SFRA results of one phase are compared to the results of the other phases of the same power transformer under test. 20 Hz to 2 kHz, it deals with core winding inductance. 2 kHz to 20 kHz, it deals with bulk winding component. 20 kHz to 1 MHz, it deals with main winding. 1 MHz to few 2 MHz, it deals with tap winding and internal leads. The dissipation factor, DF, test, also known as the tan delta test, is used to assess the insulation quality of transformer. To measure dissipation factor, first the high voltage winding should be shorted and the same for low voltage windings. Then apply AC voltage to high voltage windings, measure the dissipation factor, tan delta, and analyze the ratio of resistive to reactive components. Modes of test in dissipation factor devices. UST mode. The ground lead serves as a guard mechanism to divert current from being measured. The measured capacitance is between high and low winding. In GST modes, there are 2 types: GST guard and GST ground. Both measure current flowing through the ground path. The measured capacitance is between high and low winding and high or low winding with ground. The equivalent circuit and phasor diagram. The equivalent circuit of the dissipation factor, DF, test for a transformer is derived from the transformer's insulation system and can be modeled as a parallel combination of resistance, R, and capacitance reactance, XC. Acceptance criteria according to NETA ATS with Table 100.3.